make them all available, but it's a lot more difficult than you might think. And it's just got various things to help you troubleshoot one of these valves. You know, it'll tell you what the liquid line temperature should feel like and what the head pressure controller should be doing in various situations. Water-cooled condensers, tube in tube. The water flows in the inner tube, the refrigerant flows in the outer tube. The two surfaces for heat rejection. Because it's in the outer tube, the refrigerant it can radiate that heat outward, and that heat's going to go into the water as well. There's two types, the coiled, two separate tubes, one inside the other, coiled, and flanged, two separate tubes in straight sections with removable flanges for cleaning. You've seen the tube inside a tube before. This is what the flanged looks like right here. The flanges are taken off so you can kind of see it inside it, but it's basically the same principle as the tube in tube. The outside is refrigerant, the inside is water. And this is just the first of the water-cooled condensers that they had. There's the tube in tube condenser. Do try and remember with the tube in tube, I'm sure it's going to come up on the slideshow here shortly, that you've got your water tube, got your refrigerant tube, and the water is going to come in where the gas is coming out. The water is coming in to subcool what we've already condensed. And because the temperature gets higher and higher and higher as it goes through, gets closer and closer to the discharge straight off the compressor, it can continue to pick up heat the whole way it goes through. So the refrigerant and the water are moving two different directions. They're moving in opposition to each other in these coils. Water in, we're going to go through around the compressor, pick up a little heat there into the condenser, subcool, condense, and then begin to de-superheat as the water comes out. And there's the water coming out. In the flange type condenser, the discharge gas enters the top, leaves the bottom, and the water's coming in the bottom and leaves the top. Pretty much just like the tube in tube. It's just a slightly different design for, you know, we would probably have done the tube in tube all these years, but we couldn't do it when we used the flange. So the flange worked out for us for a time anyhow. Water on the outside, refrigerant on the inside. Remember, the refrigerant can shed its heat to the water, but it also can radiate that heat out into the atmosphere. So that refrigerant has two options for condensing cooling. Here's a water regulating valve. You'll notice that you can adjust it with your refrigeration ratchet. Incoming water and out to the condenser. Then the head pressure pushes on the bellows, which is going to open or close that water to allow more or less flow depending on how much heat you have from the condenser. Use the service valve wrench to adjust water flow to maintain head pressure. Tube and tube coiled condensers. Following picture is a cutaway view. Water uses the inner pipe, refrigerant circulates around it. And here we go. Of course, this one is pretty bad actually. I mean, as far as things go, they've really got quite a bit of accumulation of minerals inside that coil. It's always been a problem with water coils. They do now have a product that you can put on any metal pipe that will send an electromagnetic waveform into that pipe, and it will vibrate in such a way that the minerals don't stick to the pipe. And you can do that for plumbing problems or what have you. I've considered doing it to my house, but I've got some of that older pipe in there, and I'm afraid the minerals is what's holding the pipe together. It's normal water in while refrigerant is coming out, or hot gas in, water out. Shell and tube water cooled condensers. Shell and tube, a tank shell for condensed liquid, and straight water tubes through the steel shell. So that's kind of like our chiller barrels, more or less, is what they are. You know, in the barrel itself, we have our refrigerant, and then we've got multiple pipes going through the thing that's water circulating in it to try to remove the heat from the refrigerant. End caps or water boxes distribute the water. Note the shell and tube water cooled condensers are also called condenser receivers, because you can, more or less, it's a receiver condenser combination. Everything at the bottom where that's condensing, that's the receiver part. In the middle, it's a condenser. And here's a water-cooled condensing unit with shell and tube condenser. There's the shell and tube right there at the bottom. And then we've got our compressor here. So this is just a compact little condensing unit right there, except it's a water condenser on.
So it's basically the same thing as the flange style, except for it's a lot bigger.
Yeah, somewhat.
Instead of a bunch of tubes, it's kind of one big tube.
Well, there's the big tube, and it's got refrigerant coming in and out, and then the water is going through lots and lots and lots of tubes all throughout here. Depending on the construction of it, maybe it'll take one pass through there, maybe it'll take two, but for the most part we got water in, water out, and then refrigerant in and refrigerant out. Shell and tube water condenser, there's the water in and the water out of it. So this one's going to take two passes, one through and then one back. And then we've got hot gas there going in the top and liquid coming out the bottom. which of course that's where the liquid's gonna settle. It's a condenser. And here's what the tube pattern looks like in some of these. You got this whole, the water's going through the tubes, and beyond the other side of that, that's where the refrigerant is coming through, and the heat is absorbed into the water, and then liquid refrigerant settles down toward the bottom and drains out. The tubes circulate the water to condense the hot gas, showing scale build up in the tubes. And in here, there's a broken off cleaning rod. Acid cleaning water cooled condensers. Disconnect the existing condenser water lines, connect both lines from an acid pump solution, put acid pump into dilution solution of acid, turn on pump and circulate the solution. So basically you just got a pump, you're connecting it to the water lines, and you circulate an acid through that thing to try to get rid of the mineral buildup that occurs inside it. Flush the acid and reconnect the original water lines. They got a little note here. Be very careful when working with acids. Follows instructions as to the use of gloves, eye protection, ventilation, and most importantly, proper dilution. That's so important, guys. I've seen some fellas decide that they don't need to follow the directions. They're just gonna make the acid because they think they know better than the directions, and ended up hurting themselves or somebody's condensing unit or killing all the grass in the yard or something like that. Always use the proper dilution. And here we have an illustration of an acid cleaning of a flange type. And it's really a demonstration because it doesn't even have the flange on there. Acid cleaner and the acid pump comes through here, into there, and circulates through all the water tubes. Microchannel condenser coils. They're flat plates or channels. They replace round tubing. The newer design increases the condenser efficiency, which really right now with the higher SEER units, you were talking the other day, Spencer, about how big your unit was because it was a high efficiency unit. You know, the coils just get bigger and bigger and bigger. Well, these flat plate coils, you know, a round coil is just, you got this round tube and then you got aluminum fins. The flat plate turns out to be a fin itself. And then they just put little corrugation of metal in between to help the heat transfer in between as the air passes through it. So it increases the efficiency of the condenser quite a bit, even though a lot of techs are just now figuring out how to work with them. Condenser size is reduced, and that's what it looks like right there. You see the little flat plate, and it's got little channels in there for the refrigerant to run through, and then in between it's got air channels for the air to run through. It looks a little bit more like a car radiator than it does a condenser coil, but they work pretty well. So all through these little channels, the refrigerant is flowing, and then in the middle we've got air being pulled in there to take the heat away from the refrigerant. But you can see with just a round pipe how much less contact with the surface area we would have. And by flattening that out and putting those little channels in there, we're really making a difference as far as the heat exchange from the refrigerant to the coil itself. These are all aluminum coils. Once again, copper has a tendency, copper's porous. You really don't realize it, but it is kind of porous. And chemicals can open up those pores and allow leaks, whereas aluminum is more or less protected from the environment, and it's protected from oxidization because aluminum oxidizes the second air hits it. So you've really never touched aluminum, you've touched plenty of aluminum oxide. Refrigerant flows through the channels in the flat plate, air flows through the fins. And that is the end of condensers.